So I left you on, or yesterday, finishing up lesson 7 if you didn't finish it. Let's do a quick recap. There's 2 things that you have to know about the link between fractions and decimals. I think the first link was pretty obvious. Anytime I write a fraction on the board, right, like 4/12ths, for example, this is a fraction. Some of you would look at it and say, well, it's not in simplest form, that's for sure. But what if I asked what's the decimal equivalent? What would you do if I said write that as a decimal? 0. It's 4 divided by 12, right? If you had the use of your calculator, you would type it in, and it would come up to 0.33333, right? 33 repeating. So that's the link between fractions and decimals. 1/5 would be 0.2. That's the link between fractions and decimals. It's a little more difficult going the other way, I think, right? It's not as intuitive. You don't know it as well because you haven't spent a lot of time in your day-to-day life. So what if I said to you, though, like if I gave you 0.2 and I said, convert that into a fraction. Well, if I didn't have this on the board, what you're going to do is what we learned yesterday is that every decimal digit place has its own placeholder, right? So if I think of a decimal digit, like if I just wrote the decimal digit 1, 2, 3, 4, 5. Let's say I had a 14 point, 1, 2, 3, 4, 5. This column is the tenths. This is the hundredths, right? Thousands, etc., etc., etc. We typically don't go past thousands in a high school math classroom, but this would be 10,000s, 100,000. So if I wanted to write this as a fraction, I take my 2 and I write it over, well, it's in the tenths column, so I write it over 10. That's how tenths are represented. And then I could, of course, reduce this if I wanted. Equivalent fraction would be 1/5, right? If I had the decimal digit 372, then this would be the fraction. It would be equal to the fraction 372 over 1,000, right? That's how I represent the thousands. And again, sometimes we can reduce the decimal or the fraction, sometimes we can't. But that's how we flip back and forth between fractions and decimals. Yeah? Yeah.
Anyone else need the booklet?
Okay. So, after we learned how fractions become decimals quite easily, we had to do a little more work with decimals. So just at the end of yesterday's class, we learned how to add and subtract with decimals. You basically line up the decimal digits and then just add or subtract accordingly, following the rules we learned in booklet 1, very first lesson, right? And now we're just going to do a quick review of multiply and divide. Then I'm going to give you time to finish up assignment 8, and I also have another practice assignment for you to hand in, not only for marks but for assessment purposes, right? So you know if you're doing things right or wrong. All right, let's figure out how to do this. Begin by, we're multiplying decimals. Multiply the following. I have 4.53 times 6. Now the little note above here kind of gives you some great reminder advice if you forget this. And again, we're just trying to instill that sense of numeracy without having to rely on the calculator all the time. And also to make sure that when you start using the calculator that your answers make sense to you, right? Begin by ignoring the decimals. So we multiply decimals by just ignoring the decimals at the beginning. Just multiply the numbers. After you're finished the multiplication, place the decimal dot in the appropriate spot, and the appropriate spot is you count how many decimal digits there were in the question, and that's how many decimal digits have to be in the answer. So again, this is going to be a bit of a practice too to remember how to do long multiplication, right, without the use of a calculator. So I've got 4.53 times 6. So they say ignore the decimals right away. So this is what they mean. 453 times 6. Okay, how many people remember to do this? Or how to do that? Yeah? Okay, so I do 6 times 3 is 18, right? So only one digit can go here. And I carry the 1. 6 times 5 is 30. With the extra 1, it's 31. So the 1 goes here, and I carry the 3. This gives me 24 plus 3, 27. Okay? And my question has 2 decimal digits in the question, agreed? So the answer has to have 2 decimal digits. So I count 2 from the right, and that's where the dot goes. That's it. And you can check your answer in the calculator. I think that's what you were doing, right, Christy? 4.53 times 6. And you should get the same answer, right? If you're uncertain. Now, I don't know why they give you a hint in the second one, but they said 3 decimal digits in total, which is true, right? I have 1 decimal digit and 2 here, so 3 decimal digits in total. So that's what the final answer has to have, 3 decimal digits.
Can you have to round it?
No. This time they're saying, I think in the instructions that follow, here, it says do not round answers. So you're not going to be rounding in assignment 8 like we usually do, just because we're trying to get that knowledge of the decimals coming through. Okay, so this one, I've got 128 times 14.
1.792.
Okay, oh, I'm going to do it the long way, okay? So 8 times 4 is 32. So I get 11, carry the 1, and I'm going to get a 5. Now, when I'm multiplying a 2-digit number, now I'm multiplying in the tens column, so I have to put a 0 here. And I get an 8, a 2, and a 1. I add the columns up. Okay, and now I need 3 decimal digits in my answer, so I have to have 3 numbers to the right of the dot. So that's what your final answer will be. Okay, 375 times 11. That's what my eyes see. Okay, and how many decimal digits do we have here? The answer has to have 3 decimal digits in total. DD is shorthand for decimal digits, right? This is actually really easy to multiply, right? I'm just multiplying by ones. So first I get 375. Then I add my 0 in. And I'm going to get another 375. Okay, so I get 4125. I need 3 decimal digits. So that's my answer. This is my answer to A, my answer to B, my answer to C.
Would C be negative?
Oh, thank you. Who said that? Thanks, Devin.
You're welcome.
I meant to say that when I multiplied. So a negative times a positive is a negative. Okay, D is an interesting one, right? Ignore all the decimal digits when you're doing your multiplication initially. So I just see 14 times, what do your eyes see here? Just 2, right? So 14 times 2 is 28. Okay, I need 2 decimal digits. So both of these are going to be decimal digits. We said yesterday, and I have positive times positive, so it's positive. We said yesterday that in this class I'm going to, if there's no whole number associated, like here I had the whole number of 27, and here I had a whole number of 1. If there's no whole number associated with the decimal, I'm going to add the leading 0, because that's what they require in science. So we're going to do our part in supporting the science classrooms. Okay, so E, again, it's just 17 times 5 initially. So I've got 35, 8. Okay, so this time I need, how many, oh, I guess I should have said 2 DDs here. How many decimal digits do I need here? 1, 2, 3, right? And the answer will be another negative, right, Devin? Okay, I need 3 decimal digits. I only have 2 digits present, so what do you think we're going to do here? Add a 0, right? 1, 2, 3. If you need more decimal digits, you have to add zeros. And I'll put my leading 0 there too. So that would be my final answer, negative 0.085. And just to double check, 1, 2, 3 decimal digits, so that agrees with what I was being asked to do. Okay. Okay, so this time I got to be careful. I have 0.05 times 4. 5 times 4 I see is 20, right? But how many decimal digits do I need? Right, 1, 2, 3. So 1, 2, 3. And I just add my leading 0 because there is no, does everyone have the booklet, by the way? We're doing fractions, page 20, or decimals, page 25. Yeah, okay. So this old news for most of you, I'm assuming? Yeah, good. And like I say, now we rely on our calculators for so much, but in order to use a calculator appropriately too, yeah, you've got to be able to look at your final answers and make sure that they make sense to you too, right? And that they're reasonable answers. Okay, last skill, and then we're done for all the skills you need for the test, and now it's just a matter of practicing, refining your skill. Okay, dividing decimals, that's a little different. This is worthwhile looking at too. There's so many different ways to show division, right? This is probably the first way you learned to divide numbers, with that kind of old-fashioned division symbol, which isn't really used much. This is probably the most common division symbol, but this is the division symbol you see most of in high school math, right? So the parts are important too, because sometimes the vocabulary in a question will refer to a specific part. The quotient is the answer in a division question. The big number, it's usually the big number being divided into, is called the dividend. The number that's dividing into the usually larger number is called the divisor, right? So this is how all the parts go. If I was going to show like with a real life example, I could do something like this. If I'm going to divide 12 by 3, so 3 divided into 12, the quotient would be 4. I could show it this way, 12 divided by 3, answer or quotient is 4. And this way, 12 divided by 3, the answer or quotient is 4, right? So just so you know. But like I said, this is our most common way because it's in fraction form, right? We do a lot of work in fractions. Okay, the only thing that you have to remember about division, it's kind of like the multiplication in that we do some interesting things with the decimal digits when we're doing the dividing. So with the division of decimals, the divisor must be a whole number. So that's important to note. So the divisor is this number, right? It must be a whole number. No decimals in this number here. To change the divisor to a whole number, we move the decimal point. I'm going to talk about that in a second. We move the decimal point to the right so that there are no decimal digits left. You also have to do the same thing to the dividend. Okay, so it's fancy words, right? But let's do this first one. 2 dividing into 5, or 2 by 5. This is the divisor, okay? Divisor must be a whole number. Which it is, right? Like there's no decimal digits in 5, right? So 5 is a whole number. I don't have to change 5 in any way. So now I'm just going to do my division. So this is probably worthwhile because this is something that most students haven't practiced in a while. So this is actually a useful form for doing my division. So 5 goes into 2 how many times? Well, there's a bit of a problem here, right? Because 2 isn't big enough to hold 5. Agreed? So 5 doesn't go into an even number of whole numbers. It's going to only go in part of a number is a decimal. So what I do is I add decimals and I add zeros till I get a big enough number to hold 5. 5 can't divide into 2, but it can divide into 20. Agreed? So how many times does 5 go into 20? 4 times. So that's what your answer will be. 0.4, or I would probably say 0.4, just to add that leading 0 in. Okay, 31.8 divided by 2. Can I start my division? Is my divisor a whole number? No, this is good, right? 2 is a whole number. So I can just proceed with my division. So how many times does 2 go into 31.8? Well, let's see. 2 can divide into 3, right? Once, with 1 left over. How many times does 2 go into 11? 5 times, with 1 left over. How many times does 2 go into 18? 9 times, and the dot stays wherever the dot was in the dividend. So that's the answer, 15.9.
Where'd you get the 11 from?
What 11?
Just something was 11.
3 take away 2 is 1.
It's remainder 1. It's a remainder of 1.
How'd you get to 5?
5 times 2 is 10.
2, yeah. Okay, let's try it another way. Okay, 2 goes into 3 once, right? 1 times 2 is 2. So I subtract 3 take away 2 is 1, but then I have to bring the 1 down, right? 2 goes into 11 5 times. 5 times 2 is 10. Remainder of 1, and I have to bring the 8 down, right? I have to bring the 8 down because 1 is not big enough to hold the 2. So then I get my 9. The dot stays where it was. Okay? All right, part C, problem in part C, agreed? The divisor has to be a whole number. It's not a whole number. So I'm going to explain it a slightly different way because I don't like just saying move the dot over. The divisor I can't have decimals in it. So what I do is I could say, oh, I'm just going to move the dot 1 to the right. What am I really doing when I'm moving the dot 1 to the right?
You're making it a whole number and adding a decimal place, 1 decimal.
Yeah, what I'm really doing is I'm multiplying by 10, right? That's what I'm doing. I'm kind of changing into an equivalent fraction. 0.7 times 10 is going to give me 7, right? Whatever I do up here, I have to do the same top and bottom to keep it an equivalent fraction. Anyway, that's really what I'm doing, and most students will just say, oh, just move the dot over 1, but you're really multiplying, you're just changing it to an equivalent fraction to make it easier to divide. So the bottom becomes a 7. What's 434 times 10? 4340, right? Okay, so now I'm ready to do my division. So 7 divides into 4340. Okay,
I never looked at it like that before.
that's really what you're doing, right? Okay, so 7 can't divide into 4, right? Can it go into 43? 6 times. 6 times 7 is 42. Remainder 1. I need the 4. 7 divides into 14 twice, right? Evenly. So I'm done, right? Except the decimal dot was here, was moved to here. I'm missing a number for that place value, so I have to add the 0 there to fill in that hole, because my decimal dot is right there. So negative 4340 divided by 7 equals negative 620. All right, let's see if my long division was correct. You can always check with your calculator. 434 divided by 0.7, 620, right? But it'll be negative, right? Because you were dividing negative by positive. Okay, I'm gonna get you guys to work on these last 3 on your own, and then I'll write the answers down. Then I'm gonna give you one more example, kind of a word problem example, and try to do it without a calculator, right? It's super easy to do with a calculator. Yeah.
Wouldn't you divide it by 10 in the end?
No. Because the proportion stays the same, right? It's an equivalent fraction, agreed?
Oh, okay.
If it's an equivalent fraction, the value's the same, right? Like 1/2 equals 5/10. They both represent the same value. So I haven't changed the value at all. As long as if I multiply this by 10 and this by 10, I haven't changed the value at all. Still, it's just an equivalent fraction. Okay, you guys work on the last 3, and then I'll just take attendance. Alex, Jordy, Okay, Nasa, did you do D? Yeah, okay. So I'd have to change this to 2, right? 2 divides into 0.034. Yeah? Okay, so I leave the dot where it is. 2 can't divide into 0. I have to move all the way to 3, so I have to put a 0 in here to indicate that I've skipped over it. 2 goes into 3 once. I'm going to have remainder 1, so it should be a 7. And it will be a negative, right? So my answer should be negative 0.017. Success? Yeah, good.
How did you know where to put the decimal?
It just stays where it was in the, wherever it is in the dividend, Cliff, that's where it stays.
Yeah, but isn't there two zeros behind the decimal and 34?
There's only one, because I had to move this, I had to multiply this by 10, so this by 10, so it moved over 1, right? That's
Why
what
do you
the,
have to multiply them by 10?
because the instructions said you can't divide with any decimals in the divisor. That's what it said right up here.
Oh, so you moved for the 2 over, so you gotta move it over for the 0.
That's what the instructions say, right?
Oh, yeah, okay.
Okay, here I have to move this guy over 1 decimal, so it becomes 16. I have to move the dividend it over, so it becomes an 86. Agreed. 16 goes into 86, 5 times? So 5 times 60 is 80. I have remainder 6, right? So I have to pull down the 7. Okay, so here I have to put my dot right after the 5, right? So it lines up. 6 into 67, 4 times? I think that's 64, right? Then I get remainder 30, bring down the 2, and I have a nice ending 2. So my answer, 5.42. Okay, and then last one, I'll do F over here. How many places do I have to move the dot over before I get to a whole number? 2, right? So that becomes 5. So I had 710, that's where the dot was. If the dot's not indicated, it's always right after the last number of a whole number question. So I'd have to add 2 zeros, and that's where my dot would be. So 5 goes into 7 once, remainder 2. It goes into 21 4 times, remainder 1, pull down a 0, and then I get at 2, and I'm done, right? No more remainder. But I have 1 4 2. I have 2 holes here, right, till I have my decimal dot. So those just get added with zeros. And that would be it. Now, they were both positive numbers, so my answer would just be 14,200. Now, besides doing this long division and getting all caught up in that, I want you to look at something, because this becomes important when we start doing applications. 710 divided by 0.05. Your answer is 14,200. Does that make sense to you? No. Okay, that's good. I'm glad you said that. Why doesn't it make sense to you, Alex?
Because it's less than 1. Yeah, it's just a small number.
It's a super small number. But isn't 710 a really big number?
Yeah.
So a super small number is being divided into a really big number. You should get a huge answer, right?
Because there's so many 0.5s
Yeah.
to 700.
There's so many 0.05s that go into 710.
Yeah.
That's what I really want to start stressing to you guys. Think about it, right? When we have a huge number, like let's take 1,000. Okay, let's take a big number. How many 500s can fit inside 1,000? Only 2 of them, right? But what if I took that 1,000 1,000 and I did like 0.05. How many of these little guys could fit into that huge number? Lots of them, right? Like tons of them. So how many actually do? Let's see. What do you think the answer is going to be? 200?
500,000.
That's a bit big. It's still going to be a 2 connected to 20,000 of these little guys fit in the big guy. Right? So just try and develop that sense of numbers and look at them and sort of try to, before you do your division or before you pick your calculator up, try and ballpark in your head, like not to the exact number, but just say to yourself, is this going to be huge or little, or or kind of the same size? Okay, so that's that. There's one more thing I want to talk to you about, and then I got a couple of things for you to do. I just want to talk about the word problems. Another thing I want to bring to your attention. These should be easy for you, but when we do questions like for example, here, what do I want to do? These are just calculating percents. What do I want? I thought I was going to... Okay, let's just do number 6 for a sec. Your friend ate 6 out of 24 pieces of your birthday cake. Okay, that's a lot, right? What percentage of cake did they eat? How do I turn... So your friend ate 6 out of 24. What percentage does that represent? Yeah, so it represents, you turned it into equivalent fraction, right? Did you turn it to equivalent fraction, then turn it into percent? Okay. So, and I know your name, don't tell me, because I just had it written down. I hate saying you, Danielle, right? Danielle recognized 1/4 was 25%. Agreed? So some of you, that's great. But what if it's not a common fraction? Does anyone remember how to turn any fraction into a percent? It's just like, let's say I give you a quiz or the test on Fridays out of 27 marks and you get 19. What's your percentage?
19 divided by 27 times 100.
Times 100, yeah. You can turn any fraction to percentage, just do your division. 19 divided by 27 and then just times 100, okay? That's going to be how you figure out any percentage. So that becomes 70.37%. That's not a bad mark, but I know you can all do better than that. So I'm sure you'll all get higher than that. What about if I asked you this question? I just want to do one more little thing, then I'll let you work. What if I said, find 12%, because that's our combined PST and GST in Manitoba, right? Find 12% of $190. How would you do that?
12 divided by 100 times 190.
Okay. So I heard one response. How many people, any other strategies? Like, how would you find 12% of 190? What would you do?
Or 190 times decimal 12.
Any other answers? No? Okay, so the common thing is, and some of you may have done this in other math courses, but typically a percent number is hard to use in a calculator. Some calculators don't have percent buttons. We don't really set students up to use percents in calculators because we want you to know what number that represents. 12% really represents 12 out of 100, right? That's what that number represents. So what I tell my classes to is to start, like it is 12 out of 100. So if I take 12 divided by 100, I get my decimal number 0.12, okay? But you can think of this as 12 out of 100 right now. Whatever percent you're given the number out of 100. And you know how to type that into your calculator, right? 12 divided by 100. When you're asked to find an amount of, of another given amount, of turns into multiplication. Okay, so remember that. So in your calculator, you're just going to go 12 divided by 100 times 190. And you get an answer of $22.80. So if you purchased something for $190 in Manitoba and it was taxable, you'd end up paying $22.80 in additional taxes, right? So our total cost would be $190 plus $22.80. Changes the price quite a bit, doesn't it? $212.80. So that's how you find percents of some other amount, right? Okay, so those are just two little kind of common sense things that I want to pass on to you. I've got two things for you to do then. Finish assignment 8, start and finish assignment 8 if you haven't started it. So it kind of gives you a run through of fractions, decimals. And then I also have another assignment that I'll give to you.